So next is ionic compounds. So we saw that covalent compounds are made up of only nonmetals. Well, ionic compounds are made up of a metal and a nonmetal, or more specifically, a cation and an anion. So remember, we looked at what a cation and an anion were at the beginning of this chapter. So it's really easy to spot ionic compounds. All we have to do is look at the formula. If you have a metal and a nonmetal, then you just look at your periodic table. You can see based on where the stairs are. To the left are your metals. So if you have one of those and a nonmetal, then you have an ionic compound. So ionic compounds are different. They have charges. You have your cation has the positive charge, your anion has a negative charge, and they're held together by those charges. So they don't look like covalent compounds. Okay, so ionic compounds form this lattice. Okay, so this is what they look like. Instead of like water, water was this molecule, this discrete molecule like this, right? Ionic compounds don't look like that. They look like this lattice. They have all these ions just kind of bunched up together. So this is sodium chloride. So sodiums are metal, chlorines are nonmetal, and they're just all bunched up together in this lattice. So they look different than the covalent compounds. Okay. So we've talked about cations and anions. Cations are formed when a metal loses electrons. So we know they don't lose protons, right? We talked about that. Protons are what make that element, okay? So when cation and anions are formed by either losing electrons or gaining electrons. So cations lose electrons, so they now have an overall positive charge. Anions will gain electrons and then have an overall negative charge. So be able to figure out, based on the charge of your ion, how many electrons, how many protons you have, okay? So here, magnesium, let's see here. Magnesium has 12 protons, right? I just get that by looking at the periodic table. But then it says it has a +2 charge, so that means I have two more protons than I do electrons, so that means I have 10 electrons here. Okay, down here, fluorine has 9 protons, and again, I just get that from looking at the periodic table. And since I have a negative, that means I have one more electron than I do proton, so I have 10 electrons. Okay. So on your worksheet, in your recitation worksheet, you'll get to practice some of that with the charges and figuring out how many protons, how many electrons with the ions. Oops. Okay, so ions have characteristic charges. So anybody in group 1A, the alkali metals, have a +1 charge. So there's a reason for that. We're not going to get into why that is in this chapter, but just know that everybody in group 1A forms a +1 charge when we're talking about ions. Everybody in group 2A forms a +2 charge. Now skip over all the B's and go to 3A. Everybody in 3A forms a +3 charge. Okay, now group 4, we don't use a whole lot of ions in group 4. Most of them are used in covalent compounds except for tin and lead, but they have multiple charges. We will talk about that here in a little bit. And then group 5, now we go into the nonmetals. Group 5 has -3 charge, group 6 has a -2 charge, and group 7 have a -1 charge, and then group 8 have no charge. So remember that, and again, it's it's helpful knowing what group it's in. You can write that on your periodic table for your test to kind of help you remember what what ions are formed for these metals and nonmetals. Now we'll come back to the transition metals, the ones that have multiple ions. Those are a little more confusing, but for now, just know, the group A's, what charges they have. So we have cations and anions. We also have polyatomic ions. So polyatomic ions are a group of atoms that are covalently bonded. So that means they're held together because they share electrons and they have a charge. So anytime you have a charge, it designates that you have an ion. This is just called a polyatomic ion because there's several atoms that are together with the charge. Okay, so in Canvas, I have a list of ions, polyatomic ions, and the ones in bold you should have memorized, okay? So look over that, make sure you print that out, but the ones in bold, make sure you memorize. So just to give you some examples here, carbonate ion is 1 carbon, 3 oxygen with an overall -2 charge. The nitrate ion is 1 nitrogen, 3 oxygen with the overall negative charge, -1 charge. Phosphate has 1 phosphorus, 4 oxygen with an overall -3 charge. And then chromate has 1 chromium, 4 oxygen with an overall -2 charge. And the only positive polyatomic ion we're going to be using is ammonium. And it's 1 nitrogen, 4 hydrogen with an overall +1 charge. Okay, so again, make sure you print out that handout and start working on memorizing the polyatomic ions that are in bold. Now, one side of the handout, it's, I think, monatomic ions. Okay, that's just from looking at the periodic table, so you don't need to memorize those, just the ones that are the polyatomic ions. Okay, so now we're going to learn how to put ions together to form an ionic compound. Okay, so the goal here is to have a neutral compound. We don't want to have a charge. So if I were to take, I'm going the wrong way. Here we go. If I were to take 1 magnesium, which has a +2 charge, and 1 nitrogen, which has a -3 charge, and put them together, then I would have an overall negative charge, right? So I don't want that. I don't want my compound to have a charge. I want it to be neutral. So what we do to figure that out is we take the charge, the number, and we make it as a subscript on the other element, okay? So you can see the 2 is coming over here to be a subscript on nitrogen. The 3 is coming over here to be a subscript on magnesium. So then I get Mg3N2. Okay, so let's just check and make sure we have a neutral compound. So if I have 3 magnesiums with a +2 charge, that gives me an overall +6, right? And then nitrogen with a -3 charge, and I have 2 of them, that gives me an overall -6. So I do have a neutral compound, right? The charges have to be equal. So, I call this the switcheroo. That just is an easy way to figure out what subscripts I need on the elements to get me to that neutral compound. Okay, so let's practice these. So we have calcium and chlorine. So calcium has a +2 charge because it's in group 2. Chlorine has a -1 because it's in group... Whoa. That's not what I wanted. Okay, it's in group 7. So the 2 from the calcium is going to be a subscript on chlorine. And the 1 is going to be a subscript on calcium. But you don't have to write 1, right? You can just leave it off and it's understood. So we get Ca... Oh, boy. Let's try that again. CaCl2. So calcium has a +2 charge. I only have 1 of those. Chlorine has a -1 charge. I have 2 of those. So I get a +2 and a -2. So I have a neutral compound. Okay, again, that's the goal. Okay, then we have iron. So we're going to take the 3 and put it as a subscript on oxygen. And then we're going to take the 2 and put it as a subscript on iron. So we get Fe2O3. And again, that gives us a neutral compound. So you don't have to check every time it does it. Okay, next one we have a polyatomic ion. So we are going to take the 2 on barium and put it onto nitrate. And we're going to take the 1 from nitrate and put it onto barium. Okay, so here's the thing. Let's go ahead and write barium. Barium, there's only 1. But I have a subscript 2 that needs to go on nitrate. So anytime you're writing a polyatomic ion, you don't want to change the subscripts of that polyatomic ion because that's what makes them that polyatomic ion. So instead, what we do is we put parentheses, we put the polyatomic ion, NO3, close the parentheses, and we put the 2 on the outside like that. So you never ever want to change the subscripts of this polyatomic ion because then you're changing what it is. So we just put the 2 on the outside of the parentheses. Okay, so you have to have those parentheses. If you don't, it makes it wrong. And now if you only have 1 polyatomic ion, you don't need parentheses. So I'm going to show you that in our next example here. Okay, so 3 from our phosphate is going to go over here to ammonium. And the +1 is going to come over here. Okay, so we're going to start with 3 ammonium. I'm going to come down here. So I need to put ammonium in parentheses because I have more than 1, right? So I'm going to put NH4 in parentheses. And now I have 3 of them. Okay, and then I'm going to write phosphate, but I only have 1 phosphate. So there's no need to put it in parentheses because that's only 1. Okay, I don't need to put the extra parentheses. Also, one thing to remember, or I don't think I've said this yet, ionic compounds, we use empirical formulas. Okay, so empirical formula. Okay, so all of these already are the empirical formula. You can't reduce them any further. And again, anytime you're reducing, do not reduce the subscripts on the polyatomic ions because you're changing what they are. We're only reducing, these numbers right here. But we want the empirical formula for ionic compounds. Okay. Now we're going to get into naming ionic compounds. Now that we know how to make a formula, now we can name them. Okay, so ionic compounds have different rules than covalent compounds. So make sure when you're looking at a formula, you know if it's ionic or covalent. Okay, remember ionic has a metal. Whoa. And non-metal. A metal and a non-metal. Okay, so first we're going to name the metal, the cation. I'm not going to do anything special here. You just name what the metal is. Then we name the non-metal, the anion, but we're going to put an IDE ending with the non-metal. Okay, so kind of like what we were doing with the covalent compounds with the IDE for the second one. Okay, so first we have Ki. So this is why it's important that you start memorizing those symbols and their names. That way you can name the compound. So K is the symbol for potassium. So we're going to name potassium. Whoa, I keep doing that. Sorry. Let's try that again. Here we go. So K is potassium. Okay, there are no Greek prefixes here. Greek prefixes are only for covalent compounds. So there's no monopotassium, or the next one is iodine. There's no monoiodine, okay? No Greek prefixes for ionic compounds. So we have potassium, And then I is the symbol for iodine, but we've got to change it to IDE, so it's going to be potassium iodide. Oh, I'm struggling, sorry. Let's try that again. Okay. Sorry, potassium iodide. Okay. Potassium iodide. Okay, the next one is Li2S. So Li is the symbol for lithium. So we're going to write lithium. Remember, I don't want any Greek prefixes here. So lithium. And then S is the symbol for sulfur. So I want the IDE ending, so it's going to be lithium sulfide. And that's it. Okay, one more. We have Mg is the symbol for magnesium. So magnesium. And then N is the symbol for nitrogen. Magnesium nitride. So there's no Greek prefixes there. Okay, let's do a few more examples. Okay, NaF. Na is the symbol for sodium. So we have sodium. F is fluoride. Okay. SrBr2. Sr is strontium. Br is bromide. And I don't have to worry about that too. Okay, just write strontium bromide. And I'm going to show you why here in just a second. Okay, BaO. Ba is barium. O is oxygen, so we're going to put oxide. Doesn't want me to put the little dot. Okay. Now we're going to go from name to formula. So beryllium sulfide. So first thing we need to do is figure out the symbol for beryllium. It's just Be. And then the charge for beryllium. Beryllium's in group 2, so it's going to have a +2 charge. And then sulfur, the symbol is S, or sulfide is S. And it has a -2 charge because it's in group 6. And now we've got to come up with the formula. So you could do the switcheroo and then find the simplest whole number ratio, or you can just see I've got a +2 and a -2. So if I take one of each of these elements, or each of these atoms, and put them together, then I have a neutral compound. So BeS is going to be the chemical formula, or the empirical formula for beryllium sulfide. Okay, do another one here. Aluminum. The symbol for aluminum is Al, and it has a +3 charge because it's in group 3. And then selenide, the symbol is Se, and it has a -2 because it's in group 6. And then we can do the little switcheroo thing. So 3 is going to come over here on selenide, 2 is going to come over here. And we're going to get Al2Se3. And that is the empirical formula, right? I cannot simplify that any further. Okay, next what I want you to do before you move on is I want you to get out that worksheet that you did the covalent compounds on. And I want you to work on the ionic compounds 1 through 20. Okay, so they give you 1 through 10 is the formula, and you need to write down the name. And then 11 through 20 is the name, and you need to write down the formula. Okay, so work on those before you move on, because we're going to add more rules to the ionic compound naming. And again, the more rules you start getting, the more you kind of get them all mixed up. So work on 1 through 20 before you move on to the next part.